As we fly through this endless geometric labyrinth, you get a sense of what modern computing actually feels like. Finding a single specific piece of information in the digital age is a massive algorithmic routing problem. For decades, the solution to this routing problem was simple. We relied on relational databases, which neatly packed every piece of information into strict tables, rows, and columns, acting like a highly organized digital filing cabinet. Then the internet exploded. Suddenly, systems had to process unstructured social media logs, global geospatial coordinates, and constant sensor telemetry. This massive wave of unstructured data broke the rigid tabular model. Take a look at this query flow. When a relational database tries to assemble a complete record from multiple tables, it uses operations called joins. The system cross-references every single intersection, navigating like a dense city grid without highways. Scale up to petabytes, and this maze expands exponentially. The query path devolves into an entangled, gridlocked mess that larger servers cannot fix. Software engineers shifted their focus from how data is stored to how it's retrieved. They built specialized architectures designed to provide a direct, single-step path to the information. The simplest conceptual shortcut to bypass those relational tables entirely is the NoSQL key-value store. Systems like Redis operate as massive distributed hash tables. You give the database a unique key, and it provides instant access directly to an opaque data payload without any searching or indexing. In computer science, this is known as constant time, or O of 1 access. Here, a fragmented user record is spread across multiple relational tables. A document-oriented database like MongoDB collapses these related attributes into a single JSON container. Now, one query arrow strikes that container, instantly retrieving the full record without executing slow, multi-table joins. Because these schemaless document stores aren't bound by strict relational links to other tables, they can be partitioned and scaled horizontally across thousands of separate server clusters seamlessly. By molding the database engine to match the natural, self-contained shape of the object, we eliminate the travel time required to assemble it. A traditional row-based database struggles here. To find the salary data, it loads millions of irrelevant names just to isolate that one number. Watch this data grid transform. A wide column store like Apache Cassandra flips to store data sequentially by column, isolating salary figures into a continuous vertical block. The routing algorithm shoots straight down this column, completely bypassing the grayed-out noise of irrelevant data. Physically reorganizing the data by column creates an algorithmic express lane, making massive analytical aggregations incredibly efficient. Geographic data presents a totally different challenge. When a ride-sharing app tries to find the closest driver, standard one-dimensional indexes fail because they cannot handle multi-dimensional X and Y coordinates simultaneously. To solve this, developers use spatial databases like PostGIS, which rely on a core structural shortcut called the artray index. In this visualization, you can see millions of individual GPS points rapidly grouped and consolidated into a hierarchy of nested, rectangular boundaries called minimum bounding boxes. By querying these boxes instead of testing individual points one by one, the database instantly filters out massive chunks of the map. It takes a mathematical shortcut to hit an exact geographic radius. There is an even more aggressive shortcut available. We can design the system to arrive at the answer before the user even asks the question. This is the exact function of a MOLAP cube, a specialized multidimensional structure used in enterprise data warehouses for complex executive reporting. As you can see in this 3D matrix, individual intersecting nodes illuminate as they are preloaded with data. The MOLAP cube calculates and stores every possible dimensional intersection and aggregate during the initial data load time. Because the math is already done, heavy analytical queries take zero processing time. The routing algorithm simply retrieves a pre-computed coordinate. We have fully transitioned from a world where data was passively stored to one where it is dynamically routed, mapped, and pre-computed. This trajectory leads to the active database, utilizing an event condition action, or ECA, architecture. Active databases monitor their own internal state changes in real time. When a threshold is met, the system executes a stored procedure, firing an outgoing action signal immediately. By moving this logic into the storage layer, We remove the latency of the external query entirely. At this scale, the shortest path is the one you never have to take. Retrieval time reaches its absolute limit when the architecture pushes the insight to you the moment it's created.